So I will start where I left. So we started with the Newton's first law of motion, and I try to give you an analytical understanding of the concept. Basically, what is meant by the net force, and what exactly Newtonian mechanics, or sorry, the Newton's first law, what exactly it wants you to, it wants to interpret to you, okay, in an analytical sense. So I put forward in front of you two cases, as is visible on your screen. We have a uniform mass system. It's a it's a cube, uh, because it's a rectangle, and in 3D it will be a cube. Sorry, it's a square, and in 3D it will be a cube. So this whole system is moving with velocity v. I told you that this is a uniform mass. Center of mass is at the geometric center. Net force is equal to 0. That means there is no friction, no other forces involved. And what we mean by this Newton's first law is if the net force on a body is equal to 0, the body remains in uniform motion, or it remains unaccelerated. Okay. Now, the point was that what we mean by that, that the forces are acting, that still the body is unaccelerated. That means the forces are balanced. The word net force is very important. It does not mean that no force is acting on the body. The forces are acting on the body. So this was the case number one. Now we have the case number two. We have a similar block, and that block is at rest. It might or might not be acted upon by force, but the net force is 0. This whole block will remain at rest. So this is about the Newton's first law of motion. Now let us move to the next part. It's the same part of this. It's the next law of motion. It's Newton's second law of motion. Okay, it's Newton's second law of motion. Okay, so this Newton's second law of motion, okay, what exactly it is? देखिए, you आप लोगों ने पढ़ा होगा, you might have studied it, your play chapters, that you study acceleration on the body is equal to the net force on the body divided by mass, A equal to F by M, or F equal to ME, or something else. That's exactly the definition of that. The definition which you are given in your textbooks is exactly a kind of what we call as this. We arrive at some a case arrival. Okay, and when we arrive at some case in Newtonian mechanics, then it becomes exactly what Newton's second law of motion is. Before understanding that, you need to be able to understand a concept, a technical term, and a physical quantity. What that physical quantity is called. We will talk about a physical quantity which is momentum. So whenever you come across this term, this is a physical quantity, momentum, everyone gets confused. Okay, then there is conservation, then there is impulse, then there is jerk, and there is something else. So Newton's second law is always kind of a confusion, students. So once you're clear at these things, so this momentum, what does this momentum mean? Exactly, this momentum is basically a physical quantity P, which is equal to M, which is equal to mass into velocity. The momentum is, it's a physical quantity. The body is moving. That means we are able to rule out 2 to 3 things. If the mass of a body is 0, we can't talk about momentum. There is no meaning of momentum of a massless object, because M is 0, P will be equal to 0. And second thing, if the body is at rest, that means V is equal to 0. There is no point of talking about momentum. ये दो चीजें clear है? So we will talk about momentum in case 2 things are involved. A body is moving and a body has mass. Okay. Now, it can be extension of Newton's first law. How? Because in Newton's first law, एक perspective में हमने पढ़ा है कि uniform mass and the body is moving with velocity v. That means that body has a moment. तो न्यूटन्स फर्स्ट लॉ का एक एक्सटेंशन जो आपको मिल सकता है मोमेंटम के पर्सपेक्टिव में, वो ये है that you can do one thing. You can do conservation of momentum. You can conserve it. That means It does not mean in terms of energy you talk about this, and neither energy is created nor destroyed. It's same, but conservation momentum means momentum won't go anywhere. It will come in another form. If it is in one object, it will get transferred to object number two. In what amount? What are the things that you will learn in work, energy, and power? But here, I'm talking about only the extension of Newton's first law. A body is moving with velocity, with a uniform velocity v. That means there is a point that we will talk about. It's only the extension of Newton's first law is that the body will be carrying a momentum. Now, I'm giving you another statement that in Newton's first law, if a body is moving with uniform velocity, we can conserve this moment. That means the change in momentum will be equal to zero. The change in momentum. That means change in terms you have studied from basic mathematical tools, that change in momentum is momentum with respect to time or something else. Change will be with respect to something, but here we talk about time. Now, in terms of differentiation, we talk about dp by dt is equal to 0. If this is the case, that means you can conserve it. When you can conserve it, then you can say this statement. You can repeat this statement once again, that if I am able to conserve the momentum, then what will I do? I will say that dp by dt is 0. The change in momentum is exactly 0. In case of dp by dt, what you will write? In case of p, you will write m. You can write it as this: d mv by dt is equal to 0. If the mass is constant, you can take the mass thing out. If the mass is constant, you can write m. Can you write it? dv by dt is equal to 0. M dv by dt is equal. What is dv by dt? Acceleration, change in velocity. What can you write from this? M a is equal to 0. This is what you are being able, what you are taught is this. This is just kind of a special case. So once you study Newtonian mechanics, once you study the Newton's second law in that manner, that means you keep the mass constant and you say then acceleration is net force on mass. It's absolutely wrong. So the thing is that Newton's second law of motion is the rate of change of linear momentum. Whenever I'm talking about linear motion, a body is moving with some linear velocity. It's a linear motion. The rate of change of linear momentum is equal to the external force. The rate of change of linear momentum is equal to the external force. dp by dt is equal to f ma. तो कहने वाली बात यह है कि किसी भी बॉडी का लीनियर मोमेंटम तभी चेंज होगा जब हम बाहर से एक एक्सटर्नल फोर्स देंगे, और वो एक्सटर्नल फोर्स होता है मास इनटू एक्सेलरेशन. अगर आपके पास बॉडी जो है उसका मास चेंज नहीं हो रहा है, लाइक रॉकेट प्रोपल्शन वाली चीजें नहीं हो रही, क्या आप समझ सकते हो ये चीज? इसमें कोई कंफ्यूजन तो नहीं हो रहा है? सो द न्यूटन सेकंड लॉ कैन बी पुट इन लाइक दिस, dp by dt is equal to external force. And one important thing is that the change in velocity or in something else will always take in the direction of the force. Are we clear on this? I suppose we should be clear on this. If a body is at rest, we'll start it with some force. You'll change its momentum. What? Its initial momentum was 0, you made it something. Say you started accelerating it with some acceleration, and then it started moving. It was at 0 velocity, it started moving with 5 meters per second, 10 meters per second, 30 meters. So it gained momentum. What was the initial momentum? 0. What is the final momentum? 5. So the change in momentum, which thing brought it? It was the external force. So once there is an external force, there will be the change in momentum. Okay. For some cases, we'll take that there is no change in momentum by an internal force. Sometimes when you do the conservation of momentum, in case of a gravitation, when there is gravitational forces involved. So are we clear on Newton's second law of motion? Newton's second law of motion supposes that dp by dt is equal to external force. Here you can write Allahu Akbar. You can write D in place of T. You can write MV. Okay. By again, I will write this dt is equal to F. Then you can write M dV by dt is equal to F. Then you can write M dV by dt is A is equal to F, or you can write it A is equal to F by M. This is the Newton's second law of motion. So this is exactly the concise view of second law of motion, where we keep some things constant and we start dealing about it. So the net acceleration is force by mass. So once there comes force, there will be the change in momentum. Once there is the change in momentum, there is the external force. So what you need to understand is that Newton's second law of motion says when there is the change in momentum, change in the linear momentum. Once we talk about force, is not about torques, and we will move to the angular momentum concept. But in case of a linear momentum, once there is a change in linear momentum, there will be the inclusion of an external force. It can be anything. This is about Newton's second law of motion.